So we're continuing our work with the inequalities of the sides and angles in triangles. And in this case now we're comparing two completely independent triangles. Um, Before we saw maybe two triangles that were attached to each other. So we looked for the biggest or smallest in the entire figure. Here we're just comparing two triangles that are not congruent, that are not even attached to each other. And one good way to think about this is something like a hinge. Think of a hinge on a door. As the hinge opens, meaning you open the door more and more, then the opening becomes bigger. If you just open the door a little bit, so a small angle, you can't fit through. But if you swing the door open more, that opening, picture that as the third side of the triangle, becomes bigger and you can walk through. So again, if we have our hinge and we're using this opening, think about that as the third side of the triangle. If you only open the door a little bit, you can't fit through. But if you open the door a lot, now you can fit through no problem. So if you think about the vertex of the angle like a hinge, this is going to make this section a whole lot easier. So we're comparing two non-congruent triangles. And by knowing some basic information, we are going to infer the outcome of the third piece, whether it's an angle or a side. So we have something it's actually called the hinge theorem, or SAS inequality. Remember, we used SAS, oh man, sorry. I apologize. We've seen SAS before. Side, angle, side. And we use that to determine if triangles were congruent. Here, we know they're not congruent. We're just trying to figure out, if we know two sides and the angle between them, how can we compare the third side? So remember, the name of the rule is based on the information we know. How we use it changes. We used to use SAS to determine if the triangles were congruent. Here, we're using SAS inequalities to determine the third side, how it compares. So again, I want you to go back to that hinge idea of opening a door. The bigger I open, the wider I open that door, the bigger that opening is for me to walk through. So if angle D is 75 and angle C is 40, well, 75 is bigger than 40, so OG is bigger than AT. Again, think about that door opening. If the door only opens 40 degrees, it might not be enough to walk through. But if it opens 75 degrees, you can easily walk through that doorway. The catch here is that the sides, the segments around that angle, have to be congruent. So if you look at the picture here, the two sides are staying congruent. All we're doing is swinging that angle or that hinge open and closed. As long as the sides are consistent, the sides stay the same, the bigger angle has the bigger third side. So again, the relationship of angles and sides that are opposite of each other. Everything has to stay, the segments have to stay consistent. But if angle D is bigger than angle C, then OG is bigger than AT. Same thing. SSS inequality is the same idea in reverse. Look at our pictures. Those those sides, those segments stayed the same. But now we know the sides, and we're going to find out about the angles. So as long as those two sides stay the same, we're comparing the third side. The triangle with the bigger third side has the bigger angle. So OG is bigger than AT. Well, then that means angle D is bigger than angle C. Again, if you think about that doorway, the door that's open farther, provides a bigger space to walk through. It's because the hinge was open more. Very simple concepts that we deal with every single day that can be a little challenging to explain sometimes. But again, just think of that open hinge. If you open the hinge more, open the angle more, then the opening to walk through is bigger. If you look at it and the opening to walk through is big, then that angle is big. That's really all we're saying here. So if we look at a few examples here, and we're just filling in less than, greater than, or equal to, we're comparing the angles and the opposite sides. Well, since 105 is smaller than 110, then AB is smaller than DE. That's all we're doing, is comparing that stuff right there. 105 is smaller than 110, so AB is smaller than DE. In question B, since the angles are the same, the segments are the same. Again, the sides of the angle have to stay the same. They have to remain congruent for these comparisons to work. Our focus is the angles and the sides opposite them. So 95 is smaller, its opposite side is smaller. 98 is larger, its opposite side is larger. We can use the same idea of small, medium, and large, except we're only comparing two things, so we don't need a medium. So MS is smaller. We're going to fill in a less than symbol. 28 with ET, 31 with TG. Smaller, longer. 28 is smaller than 31, so ET is smaller than TG. And we can fill in our less than or greater than symbols. We could do a few more examples here. Since the sides are the same, the angles are the same. Again, angles and sides that are opposite of each other. 8 is large, 7 is small. Then angle 1 is large, angle 2 is small. And that can let us fill in our less than or greater than symbols. Angle 1 is greater than angle 2. In this last one, angle 1 is less than angle 2. Because angle 1 is opposite to 12, and angle 2 is opposite to 13. Sometimes the questions get a little bit more challenging. Here we're just matching information and results. So let's check this out one piece at a time. In number 1, AB and BC. Those are congruent. Now we're asked to compare, or we're told angle 1 is greater than angle 2. So angle 1 and angle 2. So we're going to split it. Angle 1 is larger. Angle 2 is smaller. So we're going to stay in the triangle, and we're going to go to the opposite side. Large to large, small to small. So we can see AE is large and CE is small. So our answer here is D. I'm going to erase it and keep going. And we're going to use a process of elimination if we have to. So number 2, AE and EC. So those are the segments, and they're telling us that AE is large and CE is smaller. AE is greater than EC. Now we have AD is equal to CD. So those two are congruent to each other. So again, we want to be able to see the triangles that we're working on. So we're just going to split this right into 2 triangles right there. Trace our sides back to our angles. Bigger angles opposite the bigger sides. So AE is large. That means angle 7 is larger. Angle 8 is smaller. So our answer here is A. The picture is the challenge in this example. Let's look at number 3. Angles 9 and 10. Okay, so let's find it. Angle 9 and angle 10. So those are our 2 triangles. And angle 9 is the smaller. That's the larger. We're told BE and ED are congruent. Those are the sides there. Okay. So again, angles and sides that are opposite of each other. Angle 10 is large. Opposite that is the larger side. Angle 9 is small. Opposite that is the smaller side. So AD is larger. And we can see our answer is B, which means by default, number 4 is C. In these last 2 questions, we're asked to write an inequality. We're going to approach it the same way that we have been. We're comparing the 65 and the 70, so we have a small and a large, and they're opposite sides, small and large. We cannot solve for x. We're just asked to write an inequality using x. Well, x compares to the 7. It's the opposite side, so we compare the corresponding parts. X is greater than 7. So we're using the idea of corresponding parts to make our comparisons. In our last question, again, we have our 2 angles. 30 is smaller than 38. So the side opposite 30 is smaller than the side opposite 38. So 3x plus 2 is less than 12x minus 7. And we're going to have to use some algebra skills here to solve for x. Remember, when you're solving an inequality, the only difference is when you multiply or divide by a negative, then you flip the inequality symbol. So the way you solve might affect that, or it might not. In this case, 1 is less than x, or we can flip it to say x is greater than 1. The only difference with an inequality is if I multiplied or divided by a negative, I would have to flip the inequality symbol. So we can compare two independent triangles, or even sometimes when they're connected, and make these comparisons using our small and large comparisons, and make sure that we're comparing corresponding parts, angles and sides that are opposite of each other.